Good afternoon, everyone. Can I request you all to please settle down? Thank you. A warm welcome to you all to this session at Innovate Talks. So here we talk about printing. Earlier it used to be known just as a concept where you put down some words on probably paper or anything else. Printing is much more than what it used to be years ago. Today we're talking of 3D printing. Very, very fascinating. Let's come to 3D printing on metal technology in the jewelry manufacturing. To speak about this, we have a passionate mechanical engineer with a deep focus on leveraging 3D printing to solve real-world challenges. In his current role at Imaginarium, I hope I got that right, he collaborates with industries such as aerospace, defense, robotics, drones, and medical to help them unlock the full potential of digital manufacturing. He holds a master's degree in additive manufacturing and design from the Pennsylvania State University, and his expertise lies in combining cutting-edge additive manufacturing techniques with innovative design solutions to drive industry transformation. Ladies and gentlemen, let's hear it for our speaker, Mr. Priyesh Mehta. Thank you, sir.
Okay, thank you so much.
I'll just open this for you.
Sure.
There you go. Yep. Can you just check the mic?
Sure. Hello? 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 Yeah. Okay. Good afternoon, everyone. Thank you so much for taking the time and coming out here to discuss metal 3D printing with us. My name is Priyesh Mehta, as she introduced. Thanks so much, first of all, for the nice introduction. I work at Imaginarium, so I don't know how many people here have heard about Imaginarium, but we were one of the first companies in India to bring industrial 3D printing into the jewelry sector a couple of decades back now. So the founder director here is Mr. Kamlesh Bhai, so he's with us as well. But we've been working with 3D printing for almost now, you can say, comfortably 2 decades. And when we started with jewelry, we quickly realized that 3D printing can do a lot of other things apart from jewelry as well. So now in Imaginarium, we have 5 different verticals which are leveraging the use of 3D printing or additive manufacturing in different applications. So maybe I'll talk a little bit about each one. So Rapid, the vertical which I lead, we make parts for aerospace, drones, defense, medical, healthcare, electric vehicles, and a lot more. I'll show you in the subsequent slides with 3D printing. So for a lot of people who feel that 3D printing is used maybe in jewelry, dental, not so much serious in industrial. Currently, if you're flying an Indigo flight or a AirAsia flight or a Akasa flight, you are sitting in a plane which has an engine where a lot of components have already been 3D printed. So 3D printing is already amongst us. It's just that very few people kind of know about it. Jewel Tech, this is how we got into 3D printing. So Kamlesh Bhai leads Jewel Tech. We do casting, we do like fine jewelry, precious jewelry. Even now statues, we have a new division called Imaginarium Divine, where we are only making statues, god idols, etc. We have a specific team of biomedical engineers who are solving patient-specific problems with 3D printing. Now 3D printing works really well in areas where you have mass customization, which means high variety, low volume. Jewelry is a great example of this. So what better example of customization than a human body? Every face is different, every hand is different, every leg is different, every teeth structure is different. So we're utilizing this day in and day out. And the rest, I think, solutions where we are consultants, we help customers and industry leaders leverage this technology, adopt this technology, implement and scale up this technology. We use a crawl, walk and run method here, where we crawl with the client, walk with the client, and eventually let the client run on their own. We also have academy and ventures where we do a lot of incubation, education, etc. Because technology, even though it's been used for so many years, is still nascent to a lot of people. So that's what we are trying to change. Uh, these are the range of technologies which we offer, and you can see that we are AS9100D certified, which is a certification you need to produce airworthy parts. So, which means a lot of parts which we produce in our factory are already flying, either in fighter aircrafts like MiG-29, MiG-21. I'll show a couple of examples, later, or maybe in commercial aviation aircrafts as well. We have a 30,000 square feet in a facility in Vasai, so all of you all are open to visit if you want to experience 3D printing live. We've recently opened offices in Zurich and the US as well. So these are some of my favorite examples. These are just coalition. Let's focus on the left one first. So these are medical implants and prosthetics. This specific case is a very nice example. So we had a doctor who had a patient who had undergone a trauma incident, which means his cranial helmet was broken because of a road accident, bike accident. So the challenge was that if the construction was not made within 24 hours, the cranial and the brain part could have been, infected, bacteria, fungus, whatever, would have infected that. So the doctor challenged us with the problem that I need an implant specifically designed for this patient within 3 days. And this was like the first challenge for us. So what we did is we took the CT scan data, we converted it into a 3D file, we printed this in titanium. And mind you that we had to make sure that it's not super heavy, because otherwise, it would have been super heavy for the patient as well. So we did some design optimization, and it's been 7 years. The patient is running fine. He, continuously keeps thanking us. So this is the kind of impact which we are making, right, in the world. Another case, let's talk about this, helmets. So a lot of young children have issues with respect to their cranial lines. I have a 2.5-year-old son. Uska cranial line abhi bhi dikhta hai. Because people who have C-section deliveries or maybe suction deliveries, उसमें इतना नहीं होता है, but normal deliveries में इतना दिखता है. So cranial helmets, जब भी cranial lines होता है, कभी-कभी there is a chance of deformity of the helmet. So इसके लिए we make a helmet specifically for the child. So CT scan, design, custom print, and manufacture. So these are the medical applications. Let's focus on this one here. So this is a door handle for a MiG-29 aircraft. So MiG-29, during COVID, the supply chain was completely blocked, right? No parts were coming or going out of India. But those aircrafts have to be serviced. Every 3,000 hours, the part has to be changed. So the Indian Air Force and both of us, Imaginarium, collaborated, and we reverse engineered this part so that guys did not have any drawings, any CAD, nothing. वो लोग आए, भाई ये मेरे पास टूटा हुआ पार्ट है, आप बना सकते हो क्या? So we reverse engineered the part, we created the digital file, we 3D printed in titanium. Testing. In aerospace, testing is a huge pain because you can't just put any part on the plane, right? So we went with 3 months of rigorous testing with HAL, and now this part you see is flying right now on any MiG-29 aircraft which you see in India. This is for ADNOC. We have an office in UAE. We do a lot of work for Abu Dhabi National Oil Corporation. Can talk about it more. This is for Porsche. I'm a big car buff and Lamborghini. So Porsche came up with a problem that they wanted to reduce the weight on their part. This is a gearbox housing, part. And earlier this was 8 parts. So using our engineering, this thing, people say that in India में यार engineering नहीं होता है. इंडिया में सिर्फ मैन्युफैक्चरिंग होता है या तो स्वेट शॉप होता है या तो IT services या तो hospitality होता है. So we had Imaginarium are every day trying to change that, change the mindset. So this part was completely engineered from 8 parts into 1 part, 40% lighter yet 20% stronger. And if you own a Porsche limited performance vehicle, this part is on there. Let's talk about jewelry, why we are here for. So jewelry 3D printing has been doing and will continue to keep doing wonders. Let me talk about this specific case. So this is one of my favorite designers. She's an Austrian designer called Marie Boltonstone. Okay, and usually अगर आपको ये बनाना है तो आपको अलग-अलग पीस में बना के सोल्डर करके उसको वेल्ड करना पड़ेगा. This entire piece has been printed in a single piece. Also, ये जो beads है अंदर are not added after. So the machine has been stopped in between, beads have been added, and then it went on to continue the part. So truly a single piece design, right? We'll talk about this entire bracelet. ये पूरा single piece में बना हुआ है. with 3D printing. And of course, I'm going to talk about more examples. And while we're talking about this, for people who want to experience parts, we have Sudev here, who has these parts and platforms here on the front desk. Sudev, can you raise your hand so that people can, yes, thank you. So, for all those who want to see how 3D printed parts look like, feel free to get in touch with Sudev later. So let's talk about what's happening right now, what's happening currently, and what are we trying to change. And what I mean by we is, here we are talking about both, it's a joint project between CFC and Imaginarium. So CFC, Mr. Ravi is here, who's the CEO at CFC. So we did a lot of brainstorming and, kind of within 1 year, we were able to execute this project. So it's, I've never seen this kind of speed in government projects. Ravi bhai, I hope it's okay. ऐसा बोल सकता हूँ. So currently, this is, and that's why I've carefully used this word yesterday, right? Because what we are doing is 3D model hai, either we are printing wax or plastic, casting, master, rubber mold, wax, etc. I think all of us are familiar with this process. But this is what we feel is already today and the tomorrow. Where you go to a factory, imagine the size of your factory from 2 floors, 3 floors, and so many departments to only 3 steps: design, direct digital to metal print, and then finishing and polishing. So today, as factory owners, I'm a factory owner, myself in my current role. यार वो salary time पे नहीं आया तो whatever issues, वो leave पे चला गया बंदा, किसका शादी हो गया, किसका मम्मी हो गया, किसका ये हो गया, all those problems as factory owners. Imagine for a minute that वो कोई problems नहीं है. There is a concept called lights out factory. A lot of people here, or even in this stall, are trying to pursue export customers like Europe, US. Now, when you go there, they ask for 2 things. One is, are you sustainable? Green hai ki nahi? And the third one is, what is your dependency on labor or manpower? So, India, we have an advantage because we have access to efficient and affordable labor. But वो advantage ही कभी-कभी अपना disadvantage बन सकता है because you can't scale up. Of course, a lot of companies have scaled up. But imagine today, you actually can run your factory in 3 departments. Just 3 steps. And then, this actually also challenges the retailers because अगर 3 department ही है, तो why not have the factory at the retail point of sale at all? It's an open thought. Not sure सब manufacturer लोग हैं इधर तो कितना मेरे को गाली देंगे कि कितना appreciate करेंगे ये thought के लिए. But that's the vision. So Bolton Stern has done exactly that, where a customer comes in, designs or co-designs the part with the retailer. After a couple of hours, they see a movie or whatever, they come back, it's on, 5th Avenue, and 5 hours later, they take their jewelry back, right? So this is the dream. So we talk about CFC, and maybe this video will give you 2 information. One is, what is CFC and what they are doing. Second is also in-depth kind of know-how into the process. Okay, metal 3D printing hota kaise? It's not magic. For me it is, but I hope that it's not rocket science or the other way for you.
Welcome to Bharat Ratnam Mega CFC, India's first revolutionary state-of-the-art facilitation center designed for the jewelry industry, enabling the vision of an Atmanirbhar Bharat. Bharat Ratnam Mega CFC proudly stands as the home of India's first 3D metal printer for the jewelry manufacturing sector. We specialize in 3D printing with titanium, gold and platinum, ensuring precision and artistry in every piece created. CAD files, the blueprint of each creation, is where it all starts. Skilled designers meticulously plan and craft each detail, ensuring precision and excellence. The printing process begins with atomization, with solid metal converted into fine atomized powder. The control panel is the nerve center of the atomization process. Its intuitive interface manages and monitors each unit for seamless, precisely controlled operation. Here, a plasma beam precisely melts and breaks the metal coils or rods down to create high-quality atomized powder. The machine's gas circulation system maintains a secure and stable environment. critical in ensuring operational integrity and safety during this process. The atomized powder is then collected into this container. Just before printing, the atomized powder needs to be filtered. The sieving station, using advanced ultrasound technology and a mesh size of 60 microns, maintaining fine powder consistency. The refined powder is then carefully loaded into the metal 3D printer. The print process is now ready to commence. At the core of this operation is the laser powder bed fusion, LPBF technology deployed. It meticulously builds designs layer by layer, delivering exceptional accuracy and detail. Once printing is complete, the build undergoes depowdering, unveiling the initial form of the final product. The parts are then subjected to heat treatment in a specialized furnace to eliminate residual stresses, enhance material properties and durability of the final product. This step, while not required for all parts, reinforces product quality to exceptionally higher standards. Next, the surface finish is refined using a micro sand blaster. This ensures a smooth, uniform texture, perfecting the parts for the final stages of production. From a rough, powdery start, the journey culminates with an intricate, polished finish. Each piece exemplifies Mega CFC's hallmark precision and craftsmanship. At Bharat Ratnam Mega CFC, we are not just manufacturing jewelry, we are redefining the future of jewelry design and manufacturing, aligning Indian standards with global benchmarks in quality and technology. This is where innovation transforms creative vision into reality. Mega CFC, setting the stage for the confluence of tradition and innovation.
So I hope that video gives you an insight into the step by step. And as you saw that it's not only like control 3DP, where design aaya 3D printing, there's an ecosystem which runs behind it. And what Imaginarium and Mega CFC have done together is stabilize our ecosystem. And it's I won't say it's a fully commercial project or a fully research project. It's somewhere in the between, where we are taking one step at a time and, achieving milestones as we go. So talking about milestones, just look at the timeline. That's why I said, we've not used to working at such speed with government, semi-government entities. But the foundation of Mega CFC happened in 2024. In March 2024, we started India's first ceramic 3D printing. So I know of two companies who actually started their brand only based on this. Because ceramic is a hot topic right now everywhere. And earlier, just printing the ceramic was not the option because you have to then debind it, sinter it. So you need a lot of engineering expertise, and that's where we come in. But as we say right now, we have a ceramic 3D printer live running at CFC. Again, open invitation to anyone who wants to experience or just get a sample part as well. Second was, so the biggest problem which we had, so metal 3D printing in jewelry has been around for a while, right? But the biggest problem was every time we needed to do gold, we had to import powder from outside, which means duties, shipping, taxation, because ये same presentation और ये same topic पे presentation 6 साल पहले भी मैंने कोयम्बतूर में एमरल्ड में किया था, right? And from there to now, one thing which has changed is our powder import dependency is not there now. We have installed India's first atomizer. Atomizer, as you saw in the video, is a machine which produces powder. If you put in any form of metal, अपन jewelry में लगड़ी बोलो के wire बोलो कि कुछ भी बोलो, the concept is that if you put in any metal, you'll get a powder, and powder is the raw material which you require for the 3D printer. So now that we are able to make it ourselves, we are actually truly making all the constituent elements in India at Andheri. So किधर भी बाहर जाने का अपने को, there is no requirement. And I can say in June 2024, we started production of titanium jewelry. So whatever parts you see right now with Sudev and the team is all titanium jewelry. The same kind of finish and accuracy we will be able to see in gold as well. Gold was not ready yet till day before yesterday, right? Where we produced our first gold powder batch, atomized gold powder batch. Again, it's a research and development project. It means ऐसा नहीं है कि gold powder आज we do and we can tomorrow install in a 3D printer. Takes time, takes a lot of metallurgical engineering design, and we are working on that topic right now as we speak, right? But you can see the progress we've made in the last couple of months, right? From nothing at all in India to now we have like a working parameter, working machine, working atomizer, and if you see the dotted line is not ending because we have many more milestones to cross, right? Along with Ravi Bhai and Imaginarium, we have many more milestones to cross, and we are looking for partners, which is a good segue into my next slide. So maybe before that, what we feel is that our vision for this project is to enable a sustainable lights out factory, right, for jewelry. How many of us have heard about this concept called lights out? इसने सुना है lights out factory? Great. So lights out factory का मतलब है कि आप हो कि ना हो factory में, when the lights are not on, the factory is still running, right? That is how we are envisioning together the future of jewelry production. कि Saturday हो, Sunday हो, Ganpati हो, Diwali हो, Dashera हो, कुछ भी हो, the factory or the machine will keep running. That's what we are pushing for, and the goal is. So, जैसे मैंने बोला कि there were a couple of challenges. I'll talk about some here. First was raw material availability, right? कि बाहर से मंगा हो, import duty, वो raw material JGPC वालों को बोला कि कोड कौन सा है वो भी नहीं पता, because we never imported gold powder. It's usually just raw material in the form of solid bar. So the solution was atomize and make your own. So with CFC, we were able to bring that dream into reality, right? And as I said, currently the trials which we did last week, we've achieved the powder with the wastage which was as low as 2%. It's actually 1.7, but when I speak to jewelers, I be very careful because वो पकड़ लेते हैं और फिर बोला अरे तुमने 1.7 बोला था यार, अभी 2 क्यों बोल रहे हो? So थोड़ा मर्फी मैन्युफैक्चरिंग में हमको सिखाया कि लेके चलने का. So 2% low wastage के साथ we were able to do the trials for atomization. Okay. Second, and this is the biggest call to action which we have in front of us right now, is designing for this technology. There cannot be a situation where you have designed something for casting or for chain making or for maybe CNC and you expect कि वो same part अगर आप 3D printing में करोगे तो business case बन पाएगा. बहुत कम chances है उसका होना, ये बहुत difficult होएगा. So that is why what we do is we want to focus on a concept called design for additive manufacturing, where we are literally and figuratively breaking the mold. जो हम लोग silicon का mold बनाते हैं ना, we are literally breaking that. Whatever design principles were there all these years, के वो shank को इतना mm thickness रखने का, वो prong को इतना mm thickness, इतना distance रखने का, all has to be revisited specifically for this technology. So Sudev and the team at CFC RD have done an excellent job. We have made a design guide with us for anyone who wants to design for this technology. And we will publish this very soon on the Mega CFC website. It's an open this thing. We don't want to keep anything with us. It's an open document. You give it to your CAD designer, and I'm sure we'll be able to come out, with some this thing. And maybe this is too early, Ravi Bhai, but we are also thinking, and happy to engage with you all as well. We are also thinking about a design competition, right? That if we can invite designers from GIA or from industry to design parts for this technology. I'll show you how those parts also look. So there are 4 basic segments where people are already using this technology: hollow lightweight, complex, linking, and custom. And this is not कि कुछ नया मैं बोल रहा हूँ, ये Google, ChatGPT, whatever is your favorite search tool, इस पे available है. And companies which are mentioned here are already doing it. So I have done an internship at Penn State with someone who was working at Tiffany. They have 4 machines already. This was 4 years back before COVID. And this is like platinum, titanium, metals which are difficult to cast are no-brainers for this technology. No brainers. मतलब वो टाइटेनियम और प्लैटिनम ज्वेलरी कोई बना रहा है तो दे शुड जंप ऑन इट इमीडिएटली बिकॉज ये वी कैन शो एंड वी हैव कैलकुलेशंस बैक इट्स एकदम मतलब वो बनिया का जैसे कैलकुलेट करो कि टेक्नोलॉजी के जैसे कैलकुलेट करो सेविंग है क्लियर सेविंग सो यप आई मीन कॉम्प्लेक्स डिजाइंस अगेन इंडिया में पॉजिटिव नेगेटिव व्हाटएवर वी सेल डिजाइंस ऑन वेट राइट कितना ग्राम का रिंग है और कितना कैरेट का ये है ऑल ऑफ अस नो वेस्ट में एमआरपी का कॉन्सेप्ट है कि डोंट आस्क टिफनी स्टोर में जाके कि भाई इसका ग्राम कितना है कि इसका कैरेटेज कितना है सो वो कल्चर ठीक है इंडिया में वो बट मोस्ट ऑफ द पीपल हियर आर मेकिंग इन इंडिया नॉट ओनली फॉर इंडिया बट फॉर द वर्ल्ड राइट सो इफ वी आर नॉट एबल टू इम्बाइब दैट डिजाइन एलिमेंट इनटू ज्वेलरी वो फिर अपने पास ग्राम में ही ये करेंगे ऑल्सो कस्टम ज्वेलरी लाइक मिलेनियल्स people who are in the range of I think 20 and 30 right called millennials कुछ भी गाड़ी मैं अभी I went with one of my cousins he wanted to buy a EV car तो बोलता नहीं मेरे को ये ऐसा नहीं चाहिए मेरे को ये ऐसा चाहिए they want things to be customized for them which means the experience now imagine एक डिज़ाइन के लिए आपको वो डायरेक्ट कास्टिंग करना पड़ रहा है या तो ये करना पड़ रहा है for one design two design custom and use this technology to produce that again I see a lot of question mark faces here. We'll have time. I'm going to spare enough time for question answers later. So please keep them with you. Economic feasibility. How can I not talk about economics when I'm in jewelry? Whatever. So currently, because the technology is new, I think overall I can say apart from platinum and titanium, the technology is a little bit more expensive for gold. And we can show you the calculations why. The machine cost is around 1.75 CR. उस asterisk मार के because उसमें GST duties वगैरह वो सब नहीं लगा है. And the making cost right now which we have derived last week itself for gold is around 575 rupees per gram. Again, this does not include finishing loss. Okay, and I have a detailed calculation for all Excel wizards here. Feel free. I have a detailed calculation in Excel in appendix on how we reached to that number. What we are also working on is to improve the loss ratio because loss bachane ka techniques are all made for casting and CNC. But we are working with a lot of post-processing guys where they will be able to design equipment where we can save the loss, gold loss in the machine, in the atomization and even in the post-processing stage. So this is the two asks which we have, which I have, which Ravi sir has to the industry. One is gold powder इकट्ठा करने को हमको नानी याद आ गया because nobody was ready to give I mean KR में मेरा gold because it's a trial R&D base and stuff like that. So if anybody wants to be a part of the consortium or of this partnership where they want to try out, please come. CFC is just inside. Seeps Raviva is there. Sudev is there from our team. We'll be more than happy to talk to you. And second and the most important, this itna important nahi hai. We managed with whatever this thing we have is the design support. Okay, we need people to think outside the mold, literally and figuratively again here. We need designers कि आपने किधर कोई idea देखा है, concept देखा है, and your current CAD designer और बोल रहा है अरे सर कैसा बनेगा, right? Where the manufacturer or the designer is restricting your creativity. This is an amazing tool for you to explore, right? Because what you see in CAD, what you get in hand, थोड़ा difference अभी भी है, right? I'll show you a nice sample which we have. It's of some guru in Karnataka. उसका दांत भी दिख रहा है, छोटा छोटा जो दांत का crevices है वो भी हम लोग ने प्रिंट किया है, उनका वो भी दिख रहा है. That is the kind of precision we can achieve. And also इसमें again full disclosure, we've done micro paves and stuff like that trials as well. We are still optimizing. Micro paves में अभी भी prongs जुड़ के आता है. Full disclosure, please. मेरे को बाद में मत बोलना कि तुमने बोला नहीं था इतना precision. But we are working on that. But that's why I'm saying you have to design for this technology. You can't use casting principles and say कि यार ये same 3D printing में बना के दो, वो नहीं चलेगा. And what do we assure you in return? Early access to R&D, right? You get to contribute and access at the same time to the next big thing in the jewelry industry at, more important, underline bold, almost no cost. Because CFC में already ये setup है. आपको effort करना है, आपको team का KPIs में डालना है to make sure that ये see through हो. Second is, of course, we'll give you a preferential partnership for that specific process or design which you've made कि ये sir आपका है, and this is something which you can then scale up. And of course, the third option is always there, where if you decide कि नहीं ये technology, this works for me, I want to have my own, we have a separate division which can help you consult कौन सा machinery लेना चाहिए, कौन सा type का manpower चाहिए, etc. etc. So तीनों options है, you build your own, you operate somebody else, or you transfer technology from some other one. This is my second last slide. This is the kind of work we are doing in all other sectors apart from jewelry. I think jewelry is great, but you can see aerospace and defense, we are working with ISRO, we already have a part in the space, energy, automotive, healthcare, drones and robotics. So we are already pushing the boundaries of what rapid manufacturing can do in these industries. And jewelry mein hamara heart hai, because I also started my career from the jewelry industry. I really want to make sure that jewelry also sees this cycle through adoption of this technology. Last slide, again, this is a QR code you can scan and you can get in touch with us. I am also open to talk to people about things other than 3D printing. Chess, I'm an avid chess player. I'm trying to teach my 2.5-year-old son how to play, but I think it's too soon. Manufacturing, always open to talk to people who are interested in about manufacturing. Chipotle, Mexican food, big lover. So किसी को कोई अच्छा spot पता है या तो किसी को recommend करना है please. And last, I'm a big FIFA fan as well. That's my time. Thank you so much.
Check. Thank you for that fruitful session, sir. And thank you for simplifying things so beautifully for everyone in the room. I'm going to request once again, it's an honor to have Menon sir right here with us. So please, sir, step forward and we will have a little token of appreciation handed over. Mr. Ravi Menon is the CEO for CFC. Thank you, sir. So, sir is open to questions if we have any. And all right, I'll get the mic to you. Also, there could be a possibility of you having a query and not able to share it at the moment. So please feel free to get sir's email ID. Sir, will you be okay with that?
Sure,
So
sir,
in case, so in case anyone would like to get in touch with you.
Thank you for your presentation. I have one question about your atomizer. So you said in the video the molecular size is 60 microns. Is it the maximum or a minimum? Or is it good for titanium?
So the maximum size or the minimum size, what we're talking about, is the resolution of the laser. So the laser has a spot size, right? Now, depends on how deep you are creating the melt pool, right? You can fine tune that. The precision or the accuracy depends on three things. One is the laser, one is the powder which you're using, and third is the overall environment of the build. You want low oxygen, no atmospheric gases. That's why we inert the build as well. In terms of accuracy and what the printer can do and not do, I think we are using a fiber laser, which is a 100-watt fiber laser, can achieve a spot size up to 25 micron, which if you split, right, with the D90 distribution you have, you get 16 microns.
Another question. what kind of quality problems, like after 3D printing, I heard a lot of porosity issues.
Yeah.
How we are going to address those kind of issues? Is it the same quality what you get from casting or CNC machining, or is it different quality?
Yeah, that's a great question. So I would put, and this is not for jewelry, but overall, uh, let's talk about density. Maybe that can define, the mechanical properties as well. 3D printing is between casting and machining. In machining, you remove material from a already wrought block, which means the properties, the density is 100%. In casting, the density, again, depending on what you're casting, is from 92 to 95 to 97%, right? In 3D printing, the density actually, I thought that I would have this question. Can we present this again? I have an appendix slide which might answer your question. Oh, thank you. So, oh, sorry. You can see, sir, here, this is a new alloy which, was being trying to develop by Tiffany. It's called platinum gold. बेस्ट ऑफ बोथ वर्ल्ड्स प्लैटिनम का भी प्रॉपर्टीज और गोल्ड का जो लस्टर है वो आता है तो उसमें जो हम लोग ने माइक्रोग्राफ्स वगैरह निकला डेंसिटी वाज 99.98%. ओके ये हो गया मैकेनिकल. यू कैन ऑल्सो सी द यूटीएस विच इज वेरी क्लोज टू द प्लैटिनम रॉड या जो कास्ट का डेंसिटी. द प्रॉब्लम विच यू आर मेंशनिंग राइट नाउ इज सरफेस फिनिश और ये सब. It's definitely comparable to or maybe similar to casting. And that is why I keep saying that you have to design for this technology. Some people love that grainy finish. They want that grainy finish in jewelry. उसके लिए वो लोग additional post processing करते हैं. Like linking jewelry which I have here as sample, वो बोल रहे कि I have two options. मैं 10 पार्ट बना के सोल्डर करूँ और उतना टाइम लगाऊँ, या तो मैं एक पार्ट ऐसा बनाऊँ और पोस्ट प्रोसेसिंग और इक्विपमेंट में ज़्यादा टाइम डालूँ. Currently, what challenge which we are facing also is the kind of tools available in the market to finish these parts are also not there. So again, we have to work with outside, like import those tools. I got in touch with the best of the best tool guys here. वो लोग बोलते हैं यार इतना hard कौन finish करता है, right? As a titanium, people are not used to finishing titanium. Like us in industry, because we work in aerospace, we do. But again, those tools are very crude. We print large parts. We don't need like this kind of resolution. So that's a challenge. But as I said, we are exploring electropolishing. We are also exploring, there's a deburring, automatic deburring machine. Also, there is a process called hipping, hot isostatic pressing or processing, whatever you say. It's a kind of a heat treatment process, right? Which improves the porosity value. So I cannot say that, and I'd be lying if I say that products which are 3D printed have no porosity. They have porosity, but that is what we have to work towards. A jewelry mein, sir, we are not putting a part in the space. You don't need 100% at least to my limited knowledge what I have, you don't need 100% porosity free. आपको उतना चाहिए कि जो आपका regulation है या तो जितना भी testing है वो pass हो जाए. That is possible with commercial available post processing solutions.
What my question is that our customers, jewelry customers, they are looking for mirror finish while we are doing in the gold or then platinum. How we can convince our customers? Can we get the same finish on the surface or it is a different? Because when you are going for 3D printing, the surface quality is much different than the gold. Okay.
Yes, yeah.
So is it the better way to, when we are designing, when we are taking the orders, tell the customers, don't expect the surface finish what you are seeing in the gold, or it should be different. Also, people used to do with the 10x. So what do you recommend? What kind of X we want to do for titanium?
Yeah. So
3D printed products.
I'm a big believer in taking the application, working on it and seeing it through, right? If you have a project in mind or if you have a part in mind, sir, ये jewelry का quality भी लाने के लिए it's been a DOE experiment, design of experiments करके concept होता है statistics में. ऐसा नहीं है कि first इसमें आ गया है. Sudev and the team and RD sir have spent numerous hours on working and optimizing. So we have never ever in the presentation we have shared or shared both कि this is ready now. ये industry में जा सकता है. मैं वैसा नहीं बोल रहा हूँ. But it will require some research and development, 2-3 steps. But जो company वो लेगा, उसको ही first edge मिलेगा. Right? So if you have a project, I'm sure Ravi sir will also be open. we're happy to see it through. We have the equipment, we have, because of our aerospace background, we do post-processing. I'll show you an implant, which we have. Maybe later I'll show you the page as well. वो implant में sir आपको आपका face दिखेगा, इतना polished है, right? So ऐसा नहीं है कि possible नहीं है, वो tools available है, but jewelry के लिए नहीं है. I was saying when you were saying we have polished an implant, such high glossiness, you can see your face in that implant. But that tool I have available for industrial. Jewelry के लिए मेरे को बनाना पड़ेगा. अगर need है, requirement है, हम लोग engineer है सर तो definitely कर सकते हैं. No problem.
Thank you very much.
Right now, can we do trials
Yeah.
in 22 karat gold?
Currently, we are doing 18 karat gold because
Okay.
that is the powder which we got and that is what Sheeps basically uses. But for 22 or 24, there will be a larger curve of learning because the more, as the carat increases, the reflectivity of the gold increases. So it's then very difficult for us to get the laser talking to that powder. But we are looking for partners for trials. So if you can, if you can do a joint project, machine है हमारे पास atomizer है तो why not? 100%.
ठीक है, we can do that.
And you can get in touch with either Sudev or Ravi sir, or I have also given my this thing, and we'll be happy to connect on that.
Just there was a question on the surface quality comparing to casting. I have some clarification there. Of course, it's not there yet. Because we have started this technology in 2001, and when the first machine was installed, we used the industrial resin to print jewelry part, and it was a similar issue at that time that we could not print to certain thickness, we could not print to certain quality of finish. But today it's like part of our manufacturing process, right? It was very hard for us to convince industry at that time that this is a future. Today it's part of our manufacturing process. Metal 3D printing at present, I would request that don't compare it with your casting alternatives. It's a technology that is going to be a future for jewelry industry. Why? Because it can print in metal. Now it started with steel, it started with aluminum, titanium, and now we have gold to be printed, right? So from digital to metal is a future. So eliminating all other process of printing in wax and then casting it, to the desired level, it is going to take some time. But if we don't explore this technology today, right? Today what it can do is, yes, it can quickly print part in gold, right? That's more than enough to excite us, right? Because it's eliminating all the process. So the first thing I would request that we first explore what it can do, right? The surface quality, whatever surface quality that we can achieve, we are all experts into finishing it and collecting the dust, right? The technology has gone to a level that our gold loss percentages to some of the companies has gone below 1%. So whatever we grind, we can just recollect. So the surface quality might be, yes, it is the parts which we have right now as a sample in titanium. If you look at it, it's amazing because technology has reached to this level. 10 years back, it was horrible. Today we see it's usable, right? So I think there is one, the most important part of this technology is, yes, it can print metal. The first thing that we need to understand, it can print metal. It can go to a certain extent, like you can print links, right? So you don't need to link it, right? Today people are exploring that with even wax printer, printing directly the whole bracelet into wax and casting it in one piece so that all the linking process has been eliminated. Now the same process can be done with even metal printer, right? So I think the watch cases, let's say the watch cases to a thin watch cases, and you can hollow it from inside because 3D printer can do that. Metal 3D printer can do that. Print a small wall and there is still a hollow inside, which there is no powder inside. So I think DFAM, what Priyesh has explained, that design for additive manufacturing, what this technology can do, which right now the other technology cannot do. Instead of looking at the surface quality and all other options, yes, first look at the process, the bracelet which he has sold, which has it was an experiment done by a designer. They printed halfway the whole design, then they put a stone in it, and they started printing again. Right, so stone, because it can withstand that temperature, remained inside the cage and you can create that. This is more than something to excite us, right? Now there is lot other things that to go into as an R&D. Collaborative approach will help us to, reach to that level. We have been trying these machines to come to India since many years, but there was a heavy investment. Now government and council is helping us to bring that technology. It is there in our premises now. Now we should start using it. So that's something I just wanted to explain. Thank you.
And one more promise we'll make. Yes, sir. Mike. While the mic is reaching, one more promise we make as a team is next year, same time, we'll have gold samples instead of titanium samples. So definitely.
Yeah, as you said, the design is definitely important for this additive manufacturing. Is Mega CFC is planning to train the people on DFAM?
So that's what, I mean, I just gave a glimpse of that we already have a design guide ready available with us. And if anybody needs additional consultation, we're happy to offer it. We're also planning to have like a design competition where, we'll get entries and we'll select a few and we'll actually manufacture and, see them as well. So, sir, consulting always, we are happy and Ravi sir can definitely talk about it. We can do that.
Yeah, that's important.
Yeah. But sir, why Imaginarium is well positioned to do that? Because ये technology, मतलब ये jewelry printer नहीं, but aerospace printer मैं 8 साल से use कर रहा हूँ metal में. So I know the वो बोलते हैं ना वो पाव भाजी बनाने के लिए जो मसाला है वो हमको पता है, खाली वो थोड़ा अभी डिश चेंज हुआ है. Exactly. छोटा कढ़ाई से बड़ा कढ़ाई है तो बड़ा कढ़ाई से छोटा कढ़ाई. Cool. Thank you so much.
Thank you very much, and I think with that, we come to the end of this session. The exact idea was to make sure people are here to join forces and make the best of the experts in the room. So all the best, everyone. Please feel free to connect. Thank you.